Let's have a look at the FMSynth in Caustic 3. The FMSynth produces sounds based on frequency modulation. To explain frequency modulation, imagine you had an oscillator producing a pure sine wave, and you had another oscillator controlling the pitch of that first oscillator. If you had a very slow rate of change on the second one, like an LFO, what you'd hear is the first oscillator would be varying its pitch and would create a vibrato effect. If you raise the frequency on the second oscillator, the one that's modifying the first one, what you'll get is frequency modulation. This introduces extra harmonics into the sound and gives it a much richer sound. The FMSynth in Caustic uses 3 oscillators. Now, oscillators in an FMSynth are also called operators sometimes because they affect each other in a more mathematical way than rather just combining signals. So you'll hear me use the terms interchangeably. The way the operators combine is controlled by an algorithm, and I'll explain that in a bit later. So you can see you've got operator 1, 2, and 3, and each one is a simple sine oscillator. If I set the level on number 2 and 3 down to 0 and press a note, you can hear operator 1 just playing a sine. Because all 3 operators are using the same controls, I'll just go through an example on operator 1 and you can extrapolate for the rest. The controls are the same. So first up is level, and that's just volume. Next up is a velocity button. Selecting this will set the velocity to affect the level of this operator. Because you get 3 operators, you can select the velocity to only affect a few of them, and that will change the way the sound is produced because the operators combine using an algorithm. In most other synths in Caustic, velocity only reflects to a change in the output volume, and if that's all you want, you can use the master volume velocity switch here and just set it, and that will give you the same result. So that means a note played down here and velocity set down to 50%, say. In normal case, if I haven't said anything, will produce the same sound as if it was 100%. If I set this velocity control to on, that means the output volume will be halved when this note is played. If I set this button to be pressed, that means the level output of operator 1 will be halved when the note is pressed. So if you set it to operator 2 and operator 2 is modifying operator 1, it will only modify it 50% of the amount it would normally. So this gives you a lot of control to select how velocity would control your sound. It's very useful when we're doing kind of percussive sounds because we can control the amount of hit sound on the actual percussion we're simulating. Next up are pitch controls, so standard octave and semitones. This button here controls whether or not the oscillator is driven by the keyboard note that's played, or whether or not it just emits a fixed tone. So when we're combining operators, sometimes we want kind of a ringing sound, and we can use one of the oscillators to emit a fixed tone, and that will give us kind of a reference to which the other operators will combine. And so we can control the note that's played all the time by using the same pitch control. So you can set that to what you want. In most of these examples, I'm just going to be letting it follow the keyboard. Next up is an envelope section, and that's the same as you'd find in all the other synths. The sub-synth tutorial has an explanation of the envelope, but basically it's controlling your volume over time. The extra feature on the FMSynth are these buttons. So for example, if we had set up our envelope to decay down to 0 to get kind of a percussive sound, if we wanted to emulate a natural instrument, we probably want the decay to be exponential. Right now, the decay is linear. So it means the volume starts at a certain level and just fades down to 0 linearly. For simulating natural instruments, the decay is usually more of an exponential decay. So if we select the exponential button, the decay now behaves exponentially. So the volume kind of goes down really quickly, but then settles. If you press a note shortly and then release it, in this case, with this envelope set up, my release time set to 0, so my note will cut out right away. So if we wanted the release to follow decay, we set it to pretty much the same value. That way, if you let go of the note, you get a similar decay down to 0. Because this is going to be used a lot in these FMSynths for quickly decaying sounds, you can press the link button, and that will link the decay and release parameters, and any changes made to either the exponential slope selection or the knob itself will be mirrored from release to decay. Okay, let's move on to the more interesting part of actually doing FM synthesis. So we'll leave this algorithm selected here. What this algorithm is telling us is that operator 3 modifies operator 2 modifies operator 1, and operator 1 outputs. If we bring up the level on operator 2, we'll hear what kind of effect the frequency modulation is having on the output. So you can hear how it changes the frequency content of the first operator as we raise the level or the influence that it has on that operator. So if all you wanted was having a bit more interesting sound than a sine wave, you could just leave it at this. But what's more interesting is how you modify the envelopes so that the influence operator 2 has on operator 1 gets modified in time. So let's say we set up a decay envelope on this. What we'll get now is operator 2 will modify operator 1 for a short duration, but then that influence will fade away very quickly. So now we get something that sounds more like a plucked string. Because the influence of operator 2 only affects the beginning or the plucking phase and then disappears, and we're left with a pure oscillating sine. Things get more interesting when you change the pitch of operator 2. And this changes the kind of overtones that are generated into operator 1. If we set operator 1, let's say, to also have an exponential decay down to 0, and set operator 2 to have a fairly high pitch, we get sort of more of a bell kind of metallic sound. Let's bring in operator 3 and see how it complexifies this sound even more. Now, because operator 3 modifies operator 2, its effect will also fade onto operator 1 as time is decayed, because the envelope here affects everything upwards, let's say. So in the case of operator 3, will also get modified by this envelope because it's only having an effect on operator 2. Operator 3 is not directly influencing operator 1. That'd be a different algorithm. So let's take this sound and add a bit more of kind of percussive hit to it. If we also set a very short exponential envelope on this, you can hear how the extra operator adds a bit extra attack sound to it. So what would be interesting in this case is we could set this operator to be velocity sensitive. So the harder we hit the note, or the velocity value we've set in the pattern, the more this little attack portion is going to be modifying the operator and showing up in the final sound. So this can have a bit more expressive when we're playing either through MIDI or through notes, is that the velocity will affect the final sound in a realistic way where the attack is physically less present because we've hit it very softly. So if we combine that with volume, we'll get a more realistic effect. So you get the idea. Now, operator 3 has an extra parameter to it. If you notice this little loop here, this is a feedback loop. What it means is that operator 3 can have its own output fed back into itself to feedback. What this sounds like is, instead of having a sine oscillator, it's more like a sawtooth. So it's a lot edgier. It's a bit of like distortion that's coming through. To control the amount of feedback that's going into operator 3 from itself, use the feedback knob. So if I set something up where you can actually hear operator 3, and if I raise feedback, you can hear how it's a lot edgier on the high end. So we've said the algorithm selector changes how these operators modify each other. And so if you tap on this selector, you can change the order in which the operators affect each other. So in this case, we see operator 3 affects operator 2, which is added with operator 1 to the output. So there's no influence of operator 3 or 2 onto 1. 1 is pretty much just a parallel output, and the only FM that's going on is between these two. So you've got different algorithms. In this case, 2 and 3 are added up, then applied to operator 1. In this case, it's more of like an additive synthesis where each of these operators is independent and being combined in the output. There's actually no FM going on in this algorithm. And in this case, operator 3 affects operator 1 and operator 2. So sometimes you've got something set up and you can just change the algorithm and get a completely different sound. So it's great for experimenting. And while you can get an idea of how an operator will affect another based on its pitch and envelope, a lot of it's just kind of trial and error and getting a sense for how things affect each other. Over here is an LFO section, or low frequency oscillator. The LFO can be assigned to the amplitude of operator 1, operator 2, or operator 3. It can also be assigned to the output volume. You can assign it to the pitch control on operator 1, 2, or 3. And you can have more than one of these on at a time, so it's be affecting more than one target. The only thing is, because it's one LFO, you only get one rate and depth control. So whatever values you choose will be affecting all the targets. So for example, if I set the amplitude of the output as a standard kind of tremolo effect, I best give these some sustain to actually contain them. Now, modifying the amplitude of the operators can have an interesting effect, especially if the operator is modifying another one. So in this case, if I were to modify the effect of 2, that would be effectively moving this knob, so changing the effect that operator 2 and everything above it has on operator 1. So you get more interesting effects than just standard tremolo. It's more like a filter sweep in this case. And then if you modify frequencies on top of that, you can get some really crazy results. So like all the other synths, once you've got your knobs and configuration all set up the way you like, press the disk icon and type in a preset name, and that will save out your preset as your own. You can then use it, recall it from the preset selector. The app comes with a bunch to choose from and gives you ideas and things to modify to learn how the FM works. So that's pretty much it for the FMSynth. Once you understand how the operators affect each other using the algorithm, a lot of it will make sense and you'll be able to design your sound the way you want. Play around with the pitch and envelope and you can create some really unique sounds with this synth.